Alright, today we're going to start section 2.3 and 2.4, and we're going to look at polynomial and synthetic division of rational functions and rational expressions, and we're also going to briefly touch on complex numbers as well. So we want to understand how to divide polynomials using long and synthetic division. That's the main thing we're going to focus on today. So before we get into polynomials though, let's try and see if we can remember how to do long division by hand. So hopefully you remember how to do this. Pause briefly, divide 53,281 by 17, and when you have your answer, unpause and we'll check. Okay, so hopefully you got this correct. First we do what is 5 divided by 17, that does divide, so then 53 divided by 17 is 3. Multiply the 3 by the 17, we get 51, then we subtract, and I get 2. 2 doesn't divide by 17, so I bring the 2 down. 22 divided by 17 is 1. 1 times 17 is 17. Subtract, I get 5. 5 doesn't divide by 17, so I bring the 8 down. 58 divided by 17 is 3. 3 times 17 is 51. Subtract, and I get 7. 7 doesn't divide 17, so I bring the 1 down. 71 divided by 17 is 4. 4 times 17 is 68. Subtract, and I get 3. So what that tells us then is 53,281 divided by 17 is 3,134 plus 3/17. A couple of words we want to remember just for mathematical sake. Here the 17, this is our divisor. Our result here is the quotient. This is the dividend, and then the 3 is our remainder. Okay, so the division algorithm, which we'll learn about with polynomials, but we can apply it to here just so you can see what it looks like. It shows us the relationship between all of these numbers. So the division algorithm here is telling us that the value 53,281 equals 17 times 3,134 plus 3. Or another way, or what the division algorithm is formally actually saying, is that the dividend is going to equal the divisor times the quotient plus the remainder. Okay, well what if we're not dealing with just numbers? What if we have the division of polynomials, which is what we're actually going to be dealing with today, or a rational expression? So this expression here can be thought of as either of those, as a rational expression or the division of two polynomials. So I want you to pause the video, take a minute, and divide this, and then we'll talk about the answer. Okay, so this one was pretty simple. We actually don't need to do long or synthetic division to divide this, because we can factor the numerator into x minus 3 times x minus 2. The x minus 2's cancel, and we're left with x minus 3. So the quotient here is x minus 3. There is a remainder of 0. We could have done long division or synthetic division here, but it would be more work than necessary to get the same answer. But now let's look at a problem that we can't just factor. So if we have x cubed plus x squared minus 3 over x squared plus 2. Well, now we have to use either long division or synthetic division of polynomials. So let's go over how to do that. So we want to set this up with x squared plus 2, and then we have x cubed plus x squared plus 0x minus 3. Don't forget to put in a spaceholder for any degree term that is not there. We need to have 0x, or if there was not an x squared, we need to have 0x squared. So we have to account for every degree term. So now when we do our division, x cubed, remember we're always going to divide by the first term in the divisor, and so we're never going to divide by the 2, just always the x squared. So x cubed divided by x squared is going to be x. I choose to keep that in line with the other x terms. You can write it wherever you want up here though. I just like to keep things neat so that I remind myself that when I go below here, I need to keep things in the correct column. Now we multiply. X times x squared is x cubed. X times 2 is 2x. And now we'll subtract. So this becomes 0. This becomes x squared minus 2x. And I can bring down the 3 if I want. Now I divide again. So x squared divided by x squared is going to be 1. So I'm going to have plus 1. Now I multiply. 1 times x squared is x squared. 1 times 2 is 2. Now I subtract. This is 0 minus 2x minus 5. Okay, now I can't divide anymore because negative 2x does not divide by x squared, so I'm done with the division. So how do I write my answer? Well, I know then that this over here. This equals x plus 1 plus negative 2x minus 5 over x squared plus 2. So this is how we want to write our answer. Now here I could have factored out the negative in the numerator, but I want to be very careful about that. If both of these terms aren't negative, I don't want to make that a minus. Okay, now applying the division algorithm to this, well, in terms of polynomials, the division algorithm is if we have some f of x, it equals d of x times q of x plus r of x. So r of x here is our remainder. It's a function now. So in this case, the remainder function is negative 2x minus 5. Q of x is the quotient. Again, it's a function now. So in this case, the q of x would be x plus 1. And d of x is our divisor. So in this case, that was the x squared plus 2. F of x was the function that we were dividing, or the dividend. So that was our x cubed plus x squared minus 3. Now, another way to write this, which is how we actually have our answer written, is if we divide this entire equation by d of x. So I could write it as f of x over d of x equals q of x plus r of x over d of x. And you'll see that this right here directly correlates to how I wrote my answer up here. So that's how we want to write our answer. Now just a little bit more with terminology. Proper versus improper rational expressions. If we've done our division correctly, an improper rational expression is going to be f of x over d of x. A proper rational expression would be r of x over d of x. The reason being, it's proper because the degree of the numerator is less than the degree of the denominator. Here it's improper because the degree of the numerator is greater than the degree of the denominator. So that's what we're talking about when we talk about proper versus improper rational expressions. Okay, to practice, I want you to pause the video, do this division, and when you're done, unpause, and we'll check your answer. Alright, assuming I did my work correctly, you should end up with x squared plus 3x plus 3 plus 10x plus 7 over x squared minus 3. If you did not get that, you can pause the video and look at my work here and check your work amongst that. If you have questions, you can ask me in class. Okay, now we're going to talk about synthetic division. Synthetic division is a shortcut for long division. We mainly only use it for divisors of the form x minus k. This does not mean that it has to be minus a number, it could be plus a number, so as long as it's a x to the first degree and then plus or minus a number, a real number, then we can do synthetic division. I will show you in class how we can do this in other forms as well, but this is how we normally do it. So synthetic division, what we're going to do is we're going to take what we're dividing by, set it equal to 0, solve for x, and that tells us that that's what we're going to put in our corner. Then we take all of the coefficients of our divisor, so that's going to be 1, 0x cubed, negative 3x squared, 0x, and 1. And I'm going to leave a little space and draw a line. Now with synthetic division, it's nice, we add vertically and multiply diagonally. So I bring the 1 down, 1 times 2 is 2, 2 plus 0 is 2, 2 times 2 is 4, 4 plus negative 3 is 1, 1 times 2 is 2, 2 plus 0 is 2, 2 times 2 is 4, 1 plus 4 is 5. I'm done. Okay, what does that actually tell me though? Well, I know that if I took a 4th degree polynomial and I divided by a 1st degree polynomial, I'm left with a 3rd degree polynomial. So that tells me this term right here is x cubed. So I know I have x cubed plus 2x squared plus x plus 2 plus 5 over x minus 2. Alright, well what if we want to find f of 2? Now remember, what we're calling f of x is the numerator here, the x to the 4th minus 3x squared plus 1. So what I'm saying is find f of 2, or we'll plug in 2, and then this is going to be 2 to the 4th minus 3 times 2 squared plus 1. And so if we type that into our calculator or just do some mental math, this comes out to be 5. Well, where else did we see that 5? That was, not coincidentally, the remainder. And so this leads us to the remainder theorem. And what the remainder theorem tells us is that if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So this is actually helpful because it tells us that when we're doing synthetic division, if we get a remainder, or even if we get a remainder of 0, it's telling us a point on the graph, or on the function. So I know that on this function, x to the 4th minus 3x squared plus 1, the point 2, 5 exists. If the remainder is 0, then that tells me that x minus k was a factor of that original function, and it found an x-intercept or a 0. So the remainder theorem is very useful. Okay, I'm going to stop right here because we're running out of time for 15 minutes, but I have one more example I want to do, so that'll be in part 2.